Hi, welcome to the reflectivity solution to global warming urgently needed. I'm Dr. Feinberg. Now, let's get right to it. As a good example of the reflectivity solution is the idea of cool roofs. So you can see here from the infrared, and we're all familiar with dark surfaces that absorb more heat, like roads, for example. And you can see that here, the red color indicating the heat, and on the roofs as well, the black roofs. So when you mitigate that by painting them white, as shown here at the bottom, or maybe perhaps a green color, also somewhat more reflective, that you will mitigate that heat. This is originally proposed for cooling off cities, which are for health reasons. But another advantage is it does reduce global warming. Now, hotspots are a very important issue, and that's the idea of the reflectivity solution. So let's look at that. When solar radiation falls on the Earth, well, the sun's rays initially pass right through the greenhouse gases because it's what's called shortwave radiation. But once it hits the Earth, it gets absorbed, especially by these dark surfaces. So dark surfaces, like roads, for example, and cities, will turn that solar radiation into heat. And heat is infrared, and it's the long wavelength version of the electromagnetic spectrum. And those long wavelengths can get absorbed by greenhouse gas molecules. Okay, so the point is that they will start re-radiating the heat in all directions, and some of it will come back down to Earth. So you also get like a doubling effect. You get the original heat from the Earth, and you also get the re-radiation from the greenhouse gas. So the actual number is about 1.6. So it's not quite doubling. Now, if we instead make that hotspot into a reflective surface, you not only reduce the original heat, but the greenhouse gases become ineffective. They don't do anything. So they can't re-radiate because there's no heat to re-radiate. So again, you get that big improvement not only from the original surface heating, but from the lack of greenhouse gas participating. So it's not rocket science, it's common sense. If it's hot, it's contributing to global warming. So cooling hotspots is our goal, and greenhouse gases need heat to work. So less hotspot heat means less additional greenhouse gas re-radiation heat. Here's a little greenhouse gas surface theorem to help you remember. Increasing the reflectivity of a surface has the same effect as reducing greenhouse gases. Alternately, if you decrease the reflectivity of a surface, it has the same effect as increasing greenhouse gases. And the hotspot math, the heat change, is a 1.6 factor we discussed. Okay, now there's another improvement that you will get as well. Reducing hotspots can reduce the feedback mechanism, which causes the warming of the Earth and snow and ice melting. Now we want ice around, for example, because when ice melts into it's a highly reflective surface, snow and ice, and when ice melts into the ocean, it changes from being highly reflective to the color of the ocean, which is highly absorbing. So it absorbs the sun's rays and causes more global warming. Also, that causes water to evaporate, and that evaporation is a problem. If you may not know this, but warm air holds more moisture. And why do we care? Because moisture is a major greenhouse gas. So that H2O is a greenhouse gas that can hold a lot of, that has a highly absorbing quality, much more than CO2. And as that spins out of control, that feedback causes the tipping point. So let's look at that a little bit. The important thing is that the reflectivity solution, also called the albedo solution because albedo means reflectivity, is 100% guaranteed that it will work and work quickly. There is a problem, however, with the CO2 solution because it may not work fast enough to avoid this tipping point, or example, snow and ice melting and the water evaporating. And that is very worrisome, that the tipping point. So we need a solution that will work quickly. Another reason that CO2 may not work well is because it may not be the full reason for global warming, and we'll talk about that in a little bit. So what is the problem with the reflectivity solution? Well, it's not very well known. It's not under consideration by any governments. And if you go on the internet, certainly you look at all these experts touting off about the CO2 solution. So the reflectivity solution is overshadowed. So without the reflectivity solution, the tipping point will likely occur. Now let's look at what some of the other authors are saying. Here's a chart that shows the temperature change versus year, and obviously most of this is projected. So here we are with a 1 degree change since 1950. So this is a temperature change since 1950. So we're right about here on the graph. So the rest is projected by these authors. So McMahon et al. Is a set of authors on this paper. I got this from Dunn et al., and we'll talk about that work and some of the other solutions besides painting cities white when we at the end. Okay, so the interesting thing is the red line shows business as usual. If we don't do any mitigation at all, we'll continue to get global warming and we'll spin out of control, and our planet will become uninhabitable. And you can see what these authors are saying about the Albedo solution. They say you get an immediate help, not this slow reduction here. So immediate change. And not only, I added this dash line right here to their graph because it can reverse global warming. So you can see the slow progress of CO2 mitigation. It become very difficult with a 3 degree rise. That would cause a lot of hardship. And the slow removal and deforestation, if we do forestation instead, we could get some reduction of CO2, and I think there's some inventions for removing CO2 out of the atmosphere, so that could be helpful. I'm not sure how good they would work. Another major way of mitigating hotspots is using drone technology. I thought I would throw this out here because I think it's a good idea. We could be painting tall buildings with drone technologies. Drones could be mitigating and painting hot surfaces all day long in cities, for example. So that would be a very important solution. And you can go on YouTube and you can see that drones have a very good ability to paint surfaces in tall buildings. Okay, now how much of the Earth do we have to cool? So one of the things in my paper I found was that if we choose the right hotspots, for example, we just don't, it's important to choose the correct hotspots. So we want to choose ones with high heat capacity, and because they hold a lot of solar energy. So if we can mitigate those to high reflective surfaces, well, about 0.2% of the Earth we would need to paint white, say, for example. For example, however, if we choose hotspots with heat capacities that are sort of medium and a medium reflectivity change, about 1% of the Earth. So it really depends upon the engineering equations. And in my paper, I try to make those very friendly. So these values would be for about 95% full reversal of global warming. Now, cities would be a good area to mitigate because they have high heat capacities, as well as mountains, for example. Although environmentally unfriendly to do so, we might have to do some of that. Let's try to understand this a little bit better. So I provide an example here of hot cars. So I say, do not buy a dark car. I say, what good is a Tesla car that is black? In my mind, it's a defective car and should be returned. Black electric cars, for example, can do more global warming than a white gas car, especially while parked in the sun in a parking lot. And don't forget, cars have some heat capacity, so they can store the solar radiation and discharge that extra heat later at night, say. Let's look at the difference between a dark car and a white car parked in a parking lot without the engine on. So you can see the black car, using infrared technology, is about 160 degrees, where the white car is about 112 degrees Fahrenheit. So about a 50-degree difference, and that's pretty typical, 50 to about 75 degrees, depending upon the irradiance of the day. And you can see the differences here. And using using infrared technology. So we have a lot of very good technology that is useful for global warming. But the point is that we have to be more mindful of what we manufacture, because we are continuing seeming to favor black surfaces, black roads, black roofs, and we're painting the earth black too much. And that is contributing, so it's very hard to mitigate global warming when we're causing global warming with our choice of colors, which is one of the easiest things to make different choices for. Let's look at cities, because they're one of the major problems. Yes, our cities are a cause of global warming, and I don't think anybody would disagree with that. It's just a question about how much. Cities are like parked black cars emitting heat all day long. There's only one difference: they're much worse. And they're worse because you can see that they have a large solar area. So the actual area, the solar area of the city, is much larger than the area itself of the city. So we begin to see that cities are somewhat complex. Now, something that I didn't know, but cities are actually hotter at night. Now, why is this? Because they're giant heat sinks. They not only emit heat during the day because of their poor reflectivity, but they store the heat during the day. And at night, they radiate that heat out as being large heat sinks. So they're typically between, say, 1 and 4 degrees hotter at night, and that's centigrade. So we begin to see we have two main problems. We not only have CO2 to worry about, but we have hotspots to worry about, like cities and roads. So because we have two problems, we have two solutions. So the main solution that we are looking at is the hotspot solution, the reflectivity solution. So yes, cities are hot, but they can cool. Their cooling potential is actually enormous. It's a factor between 3 and 6 times their warming ability, because we can make highly reflective surfaces. So, as I mentioned, they are a cause for global warming, and it's not just my estimates. Many scientists have done measurements and analysis, and there's a lot of controversy about how much they are causing of global warming. And my estimates show why it's difficult, because we don't really know how much of the Earth is urbanized, number one, as well as we don't really have a grasp of these amplification factors that I started talking about: their solar area, their ability to trap heat and absorption, their heat capacity. There's a lot of complicated aspects of cities. They're also hotter in humid environments because of what I call local greenhouse gas. When you rain on cities on a hot surface, it causes humidity in the air, which creates what I call a local greenhouse gas effect. So cities are very complicated, and you can see that their hotspots sway their environmental aspects, the hotspots. So mitigating them would be a really good thing. So what are the estimates that urban heat islands are responsible for global warming? Well, in my paper, based on modeling, I confirmed the possibility of significance between 4.5 to 38% in one paper, and another model between 6 and 82% of global warming could be due to urban heat islands. Again, this variability is due to the difficulty of understanding the amplification factors, as well as knowledge about how much of the Earth is actually urbanized. Now, McKinney and Michaels, based on measurements, not modeling, found controversial findings that about 50% of global warming could be due to urban heat islands. His paper was challenged and defended successfully for many years. As well, other authors have also found significance using similar measurement techniques. So the bottom line is that the CO2 solution is not guaranteed, while the reflectivity solution is a very high probability of it working. Now, As I mentioned, science indicates that the reflectivity solution is likely better and faster solution to global warming. It can reverse global warming much quicker. Greenhouse gas reduction may not reverse global warming, not only because of our slow progress with mitigating CO2, but because of deforestation. So greenhouse gas reduction plus deforestation can sort of take away the reduction that's being done, and so the net doesn't give you any reversal. In fact, if the deforestation is larger, you won't get as much effect. Now, as I mentioned, the albedo is a scale for reflectivity. So a low albedo is a number of 0 and it's a highly absorbing, where a high reflectivity is 1 or 100% reflective. And 0.5 would be 50% reflective and 50% absorbing. So we want to convert low albedo, very dark surfaces to light colors so they're highly reflective. And you can measure, there's albedo meters, so you can actually measure the reflectivity of a surface. So you might think, well, it's really ridiculous to try to mitigate these cities now that we've built, and it's taken us over 50 years to build them, so how can we do that? Well, in my mind, it's a lot faster because we're only to cool the surfaces than to build a city, because we're only talking about mitigating the surfaces. So maybe in 2 to 5 years, we can mitigate most of the heating that's being caused on the surfaces. We have solar film windows. We have surface treatments. So as I mentioned, not only is there slow reduction in greenhouse gas, and we have the deforestation, so we're going at a snail's pace. So we have very slow progress, and the continual increase in reported for the Earth's yearly increase in temperature, we see that the reflectivity solution is urgently needed. So we're seeing some desperation here. And the more we ignore the reflectivity solution, the more desperate we will get. So we might as well start touting on it now. So, as I mentioned, when you mitigate a hotspot, you also mitigate the greenhouse gas effect. So, effectively, you're taking that away. So it's sort of like reducing greenhouse gas without actually doing it. And so another point is the tipping point. As I mentioned, we have the snow and ice melting. It's called a feedback effect, because once you start your global warming with the CO2 and these hotspot stuff, that's the forcing. That's called forcing. And the feedback, the evaporation, the snow and ice melting and water vapor in the atmosphere, which is a greenhouse gas, and the fact that warm air holds more water vapor, and as water vapor is a major greenhouse gas, so the planet can spin out of control fairly rapidly. So we really need the albedo solution right away to stop the probability of that happening. So how much heat are we talking about mitigating? Well, we talked earlier about the greenhouse gas radiation, about 1.6. The feedback factor we just discussed, about 2. Changing the reflectivity of cities, we could probably increase it by a factor of 3. We talked earlier about how complex cities are for amplifying heat and their heat storage capability. So that's about a factor of 5.5. So those all combined with that heat storage to give you about a factor of 55 times its original heat that you can hopefully mitigate. So that would be very helpful. And you really kind of have to look at my paper, which I'll introduce at the end, to see where these factors come from. And you can see with artificial intelligence, we could be mitigating with drone technology and combined, we could be mitigating surfaces. And don't forget, the military has already done a lot of artificial intelligence on drones. So they have a high capability of identifying infrared objects, and could be doing mitigation. We could be using that for good purposes here. Now, we said that the CO2 solution is difficult because of deforestation, the slow reduction of CO2, and the fact that urban heat islands are likely contributing significantly to global warming. And we know that the albedo solution would do a good job in reversing the tipping point. mainly because their cooling potential of hotspots is greater than their warming potential if highly reflective surfaces can be realized. Now, I think that we are all partially responsible for reducing hotspots like black surfaces of roads, our roofs, in our houses, and the cars that we choose to buy, and hopefully some influence for city planners in reducing city heat. So we are all responsible, but in particular, I think this would be a perfect job for NASA, because we really need NASA at this point in time with their capability for an understanding of artificial intelligence that they could implement into drone technology, improve surface assessment of surfaces and how best to paint surfaces and mitigate cities, and also to work on other albedo solutions. Now, what are the other albedo solutions? Here's the paper by Dunnett, and he does a very good job, and he's pretty much atmospheric solutions he works on, where I had talked a lot about surface solutions. So aerosol injection to make the atmosphere more reflective is one possibility. Marine cloud brightening to make clouds more reflective. High albedo crops. So here, not much heat capacity on crops. So it's a good idea, and we could certainly be doing that, but I think buildings are a better hotspot area to consider. Ocean mirror effect. By foaming the ocean, we could be improving their reflectivity, and ocean has a very low albedo, but it does have a high heat capacity, so we could be mitigating that quite well, hopefully with foaming possibility. Cloud thinning might be helpful for certain clouds, are more provide more of a greenhouse gas effect than a reflectivity effect. Space sunshades is kind of shown here in the Dunn diagram. So here's the reference here on the bottom. So I think it's a pretty good article, and you can see these are all NASA kinds of solutions. So they would be very helpful to get NASA back on Earth, working full-time on this. And we really need them right now. Now, here's my papers that I wanted to direct you to. This paper, both of these papers are currently in peer review. On geoengineering and implementing an albedo solution with urban heat island and global warming and cooling estimates. And here's another somewhat related paper to this, and this is my book. So if you get a chance, you can refer people to my paper, and there's a lot of friendly engineering equations there to estimate, make these estimations. So I try to put it in a very friendly form so that people can use it. As I mentioned, currently there are no worldwide effort for the reflectivity albedo solution. So we actually need your help to pressure your representatives. And if you know, and also the IPCC, the International Panel on Climate Change, we need their help now rather than to be touting off on the CO2 solutions. We need to start looking at the reflectivity solution. As I mentioned, it's a job for NASA. So please do send out this presentation and help out in that way, and also refer my papers. And thank you very much for your valuable time. So together we can help make this change. So let's cool the earth. Thank you very much.